Let's break down everything you need to know about quadratic equations, how they work, how to graph them, and how to solve them using factoring, completing the square, and the quadratic formula. This is one of the most tested topics, so let's make sure you've got it covered. Let's start with the two forms that you will see quadratic equations in. The first is standard form. And this is in the form of y equals ax squared plus bx plus c. The other way you would see this is in vertex form, which is in the form of y equals a parentheses x minus h squared plus k. Quadratics make parabolas. So if we draw a graph, we're either going to have a U-shaped graph or an upside down U-shaped graph. What determines the way that the parabola opens is our a term in either standard form or vertex form. If we have a positive a term, our graph is going to open upward, like the picture on the left. If it's going to be a negative a term, then our graph is going to open up downward, like the one on the right. Our axis of symmetry is going to be where our vertex is, or either our highest or lowest point. Our vertex in the graph on the left is going to be at our lowest point right here. And in the second picture on the right, it's going to be at our highest point right here. To find the axis of symmetry in standard form, which is in our first form, you would want to do x equals negative b over 2a. So like I said, our axis of symmetry is going to be where our vertex is, but it's going to be a vertical line at our vertex. So once we find the x value of our vertex, we can draw an invisible vertical line in order to figure out the axis of symmetry. To get the vertex from the x value, which is our axis of symmetry, you would simply plug x back into your equation. Wherever you see an x, you're just going to plug in whatever numerical value you have. You can get a lot from a quadratic just by looking at its form. Like we said, the vertex will either give you the highest or lowest point depending on if our a value is positive or negative. The x-intercepts are where our parabolas are going to hit the x-axis. These are also called the zeros or the roots. To find these values, you would simply figure out what x is equal to when y is equal to y. So if we look at another parabola, where our a term is negative in this example, our y value at both of these points have to be 0. If we look at our y-axis, our vertical axis, it is at y equals 0. So when we plug in 0 for y, we will get two x values. And these are going to be this point here and this point here. That's where we're going to cross the x-axis. For a little review, the vertex in standard form is this x equals negative b over 2a. Again, once we get our x value, we would plug it back in to get our y. Our y-intercept in standard form is just going to be this c term. If you think about it, our y-intercept is where our parabola intersects on the y-axis. That means that our x value is going to be 0. So that means wherever we see an x, we would simply just plug in a 0, meaning that just this constant on the end, this c term, is going to be that y value. Looking at vertex form, to get the vertex from vertex form, you would want to look at your h value and your k value. And your vertex is simply going to be negative h, comma, k. The reason it's negative h is because if you look inside the parentheses, our h term, even though it's positive, there's a minus sign in front of it. So we essentially have to look at the sign and flip it in order to get our vertex. For example, if inside the parentheses we had x minus 1, you would look at this and flip it and make the h value 1 for our vertex. And again, our k, we already have a plus, so we don't have to worry about flipping any sign. It's going to be just whatever is on the outside. Let's walk through the three ways to solve a quadratic equation. So the first way is going to be by factoring. This will be the easiest way to do it. It doesn't work in every instance, but it's good to try it first because it's the easiest. The second version is going to be using the quadratic formula. This will always work regardless of what you have. We'll discuss this formula in a few minutes. The third way is going to be by completing the square. This will also work if factoring fails to work. So let's look at some examples. If we have x squared minus 5x plus 6 equals 0, again, this is a standard form quadratic equations, we would want to see how to solve it. Like I said, factoring it is going to be the easiest way, so let's see if it works. When I say factor, I mean we're going to use the AC method. This method is, we're going to multiply our A term by our C term. In this case, it's going to be 1, so we don't have to worry about it. And what we're going to do is we're going to find out what two numbers can multiply to equal 6, or our C term, but when we add them together, we're going to get -5, or our B term. You want to make sure to look at the signs for both your B and C term when trying to figure this out. So it's going to be almost like a riddle. We need to find out what two numbers will multiply to equal a +6, but add to equal -5. So the only way we can get a plus when we're multiplying, but a minus when we're adding, is if they're both negative and then they end up canceling out in our multiplication. So let's look at our factors of 6. We're going to have 1 and 6, 2 and 3. These are our only factors of 6. Like we said, both of these have to end up being negative so we can get that +6 and it cancels out. So we're going to change this to -1, -6, -2, -3. So we know that both of these pairs will fulfill that multiplication to equal +6. But which one fulfills the adding together to equal -5? Well, if we do -1 minus 6, or plus a -6, we can omit the plus sign, we're going to get -7. That's not -5. So this one will not work. Let's look at -2 and -3. If we do -2 minus 3 or plus -3, either one, it's the same one, we are going to get this -5. So we can rewrite this in factored form as x minus 2 and x minus 3. Now, what we have to do is we have to take each set of parentheses, set it equal to 0. So we're going to say x minus 2 equals 0 and x minus 3 equals 0. So our one x value is going to be 2, and our other x value is going to be equal to 3. If we had to graph this, we now know that our x-intercepts, or where we're crossing the x-axis when our y is 0, is going to be at x equals 2 and x equals 3. Again, if we had to graph this, we also know that we're opening upward because we have a +1 as our A term. So now let's look at how we can find the vertex and graph a quadratic equation in standard form. So like we said, our vertex is going to end up being our -b over 2a when we're in standard form. So if we have to rewrite this, we have our ax squared plus bx plus c. You want to make sure that your variables, in this case x, we're going from the highest power to the lowest power. That's what it means to be in standard form. So our a term is going to be this invisible 1 that's in front of this x squared. Our b term is going to be this -4. Since it's typically plus b, but we have a -4, that means that our b term is actually going to be -4. So if we replace this in our -b over 2a equation, we're going to get -4 over 2 times 1, which is our a term. Our negatives cancel out for the 4, so then we get 4 over 2, or 2. And this is going to be our x term of our vertex. Again, the x term of the vertex is going to end up being the axis of symmetry. So we'll talk about that when we graph this. So we know that 2 is equal to our x term of our vertex. Like we said, we can plug 2 back in to our equation to get our y term. So if I rewrite this down here, I'm going to get y is equal to 1, 2 squared, minus 4 times 2 plus 1. This 2 squared becomes 4 times 1 is just going to be 4, minus 4 times 2, which is 8, so 4 minus 8, plus 1. 4 minus 8 is -4, plus 1 is -3. So our y is going to be equal to -3. Now that we know our vertex, we can begin to graph. If I draw the graph over here, we know that we can go over 2 to the right and down 3. This is our vertex. So I can also draw our axis of symmetry here. So I will draw an invisible line just for reference, of our axis of symmetry. We keep talking about axis of symmetry, but what does it actually mean? Well, in a parabola, right where our vertex is, the left and the right side of that vertex essentially become mirrors of each other. So all we have to do is solve for either the left side or the right side, and then we can mirror it to the side that we didn't solve for. So I think it's easier to solve for the lower numbers, but if you want to work with the higher numbers, it's completely up to you. You will get the same answer regardless of which side you choose. So now that we have our vertex, we want to look at two values either to the left or to the right. Since we're at x equals 2, I'm going to try x equals 1 and x equals 0. So let's look at a chart. I'm going to draw a chart down here. We're going to have our 2, negative 3. I'm going to look at 1, something, and 0, something. I can also write 3, something and 4, something, but we're going to see that our 0 and our 4 are going to have the same numbers, and our 1 and our 3 are going to have the same numbers. So all we have to do now is, now that we have our x values, we want to plug it into our original equation to get our y. So if I were to delete what we wrote right here for our vertex, we'll have some room to write our next equations. So if we were to plug in 1 now, we can also plug in 3, we'll get the exact same answer, but let's do 1 since it's easier. We're going to do 1, parentheses 1 squared, minus 4 times 1, plus 1. 1 squared is 1 times 1, we still have 1, minus 4 times 1 is still negative 4, plus 1. 1 minus 4 is negative 3, plus 1 is negative 2. So we're going to get negative 2 here. Now, like I said, if we plug in 3, we will get the same answer, but I will plug it in just so we can confirm, just so I can show you. So we could do 1, parentheses 3 squared, minus 4, parentheses 3, plus 1. 3 squared is 9 times 1, we're still at 9, minus 4 times 3 is 12, plus 1. 9 minus 12, negative 3, plus 1, we're at negative 2. The same answer we got when we plugged in 1. This is because, like I said, our vertex is our axis of symmetry. We went 1 to the left at 1 and got negative 2. We went 1 to the right. It should be a mirror, and it ends up being a mirror at negative 2. So let's plug in 0. This is also going to be our y-intercept, because when x is equal to 0, we're going to get where we cross at the y-axis. So we already know, like we discussed before, that it's just going to be our c term, but let's look at why that is the case. So we're going to have y equals 1, 0 squared, minus 4, 0, plus 1. Now, 0 squared is 0, times 1 is 0, minus 4 times 0 is 0, plus our constant of 1. This is why our y is equal to 1 when we have 0 as our x. So I can plug in 1 here. Again, if we plug in 4, we will also get 1. How can we kind of know if we're correct or not? Well, we can look at what our A term was, see if we're opening in the right direction. And we want to see if there's some sort of trend, as in we're increasing constantly as we're moving further from the vertex, or we're decreasing constantly as we're moving from the vertex. You don't want to have a wavy pattern where you're going up and down. We must have done something wrong if that's the case. So if we look at our A term here, it's a positive 1. We should be going from down to up. Our vertex should be our lowest point, and our values should be increasing as we're getting further away from the vertex. So we already plotted our vertex. Now we can go 1 to the left and go down negative 2. We could do the same on the right. At 0, we're at positive 1, and like we said, at 4, we'll also be at positive 1. So are all of our values increasing as we're getting further away from the vertex? Yes, they are. Are we opening in the positive direction? Yes, we are. So this is how you would actually graph a standard form quadratic equation. Let's graph an equation in vertex form. So if we have y equals negative 2 x plus 1 squared plus 4, let's figure out how to find the vertex and how to graph it. Like I said, if we're in vertex form, it's much simpler to get the vertex. We want to do negative h comma k. So if we rewrite it with our formula, we have a x minus h squared plus k. So we look at our h term and we essentially do the opposite of it. So since we see a plus 1 in here, our h term is actually going to be a negative 1. and our k is just our regular k. So where we look at our k value, we have a plus 4. That means we're going to leave it as a plus 4. And that's going to be our vertex. We didn't have to do any math. We just had to match our h values and our k values. So let's start graphing this. If we have our graph over here, we know we're going to go to the left 1 on our x, and we're going to go up 4. Should our graph be opening upwards or downwards? Well, since we have this badly drawn negative in front of the 2, we know our graph should be opening downwards. Remember, if our a term in standard form or vertex form, if our a term is negative, we're opening downward. If it's positive, we're opening upward. So in this case, we're opening downward since we have that negative. So now we're going to create our chart again. We're at -1, 4. We can do -2 and -3. So we have 2 on the left. And then we could do 0 and 1. So we have 2 on the right. Like I said, I think it's easier to go with the smaller numbers. You can do the larger numbers. You will still end up with the same answer. So we can draw our invisible axis of symmetry here, just so we don't get confused and we can accurately mirror everything. And I'm going to plug in 0 for our first one. So we're going to have our -2, 0 plus 1 squared plus 4. We're going to follow PEMDAS order. So we're going to do our parentheses first on the inside. So it's just going to be 1. And then our exponent, which is squared, times -2 plus 4. 1 squared is just going to continue to be 1, times -2 is -2 plus 4. We're going to end up with 2. This is going to be for 0 and for -2. Let's look at what we would get if we plugged in 1 instead. So I'm going to do -2. Instead of x, I'm going to put 1 plus 1 squared plus 4. Inside the parentheses, we're going to get 2. So we're going to have 2 squared times -2 plus 4. We're going to get 4 times our -2 plus 4. 4 times -2, -8 plus 4 is going to be -4. So we're going to get at -3, we're going to have -4. And at 1, we're also going to have -4. So let's plot these. We already plotted our vertex, and we have our axis of symmetry. So we could go to 0, we're going to be at 2. That also means at -2, we're going to be at 2. At 1, we said we're going to be at -4. So right down here. And that means at -3, we're also going to be at -4. And then we can accurately draw our parabola. Let's look at how we would complete the square to solve for x. So what we're going to do here is we're going to solve for x squared plus 6x plus 5. This is going to be equal to 0. So like I said, the very first thing we want to do is let's see if this is factorable. We want to see what multiplies to equal 5 but adds to equal 6. Well, we can factor this one. It's going to be 5 and 1 that multiply to equal 5 but add to equal 6. But we're going to solve this with completing the square regardless. So what we want to do is we want to take our c term, our constant, and move it to the other side. So to cancel that out, essentially, is what it's saying. Since we have a plus 5, we want to do -5 on both sides. So we're going to have x squared plus 6x equals that -5. So it cancels out on the left, and then it's 0 minus 5 on the right. So what we want to do here is we want to take our b term, cut it in half, and then square that value. And then we're going to add that to both sides. So what we're going to do is we're going to take our b over 2, square it, add it to both sides. So our b term is just the one that has the x with it, so it's going to be 6, so half of it, squared. 6 divided by 2 is 3. We're squaring that value, so we're squaring 3, we're getting positive 9. So what we're going to do is we're going to add 9 to both sides. If we put it in on the left, it's just going to add 9. We put it on the right, we're going to get plus 4. Minus 5 plus 9 is going to be plus 4. So we can rewrite this as x squared plus 6x plus 9 equals 4. Now what we can do here is we can essentially reverse factor, and we can see that this on the left side comes out to be x plus 3 squared. The reason we know this is because we can follow the formula a squared plus 2ab plus b squared. And we can see that if we have x plus 3, our x is our a term, our 3 is our b term. We have our x squared, or a squared, times 2 times a times b. Well, a times b is x times 3. 3x times 2 is 6x, so plus 6x. b squared, 3 squared is our 9. This is going to tend to be the case when we're doing a completing the square equation. You're going to be able to get some x plus value and then square that. Anyway, this is going to be equal to our value of 4. So now what we're going to do is we're basically going to find out what does x have to be equal to in order to get 4 on both sides. So what we can do here is we're going to essentially isolate the x. So since everything is squared, we're going to square root both sides. So we're going to get, I'm going to write it on the side, we're going to have x plus 3 is going to be equal to square root of 4, which, be careful, it can either be plus or minus 2. And this is because we can square 2 and get 4. We can also square negative 2 and still get 4. So we're going to have x plus 3 equals 2 and x plus 3 equals negative 2. We subtract 3. We're going to have x equals negative 1 as our one answer. We're going to subtract 3 to the bottom, and we're going to have x equals negative 5 for our other answers. And that's how we complete the square to figure out our x values. Now let's look at solving using the quadratic formula. So if we're going to use the quadratic formula, we need to know what it is. The quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. There's a lot of variables here, a lot of numbers, a lot of operations that we have to do. If you write this down and memorize it, it'll be much easier. Like I said, if you don't know how to solve a quadratic equation, how to get the x values, maybe factoring doesn't work, you don't remember how to complete the square, the quadratic formula will always work. So it's a really good formula to remember. And again, we're just going to match up our b's, our a's, and our c's. So if we have a formula, as an example, if we have 2x squared plus 3x minus 5 equals 0, this isn't something we can factor. What we can do is we can match up our a's, our b's, and our c's. You want to take note that this c is not 5, it's going to be negative 5. So if we were to match up everything, we're going to have negative b, so our b is 3. I'm actually going to write a little table here. Our a is 2, our b is 3, and our c is negative 5. So now we can just plug it in. So negative b is negative 3 plus minus square root of b squared, so 3 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which is 2. So let's simplify this a little bit. We could do negative 3 plus minus. Let's solve everything under our square root. So our square root is essentially 9 minus 4 times 2 is 8 times 5, negative 5 is negative 40. So it's 9 minus negative 40. These negatives cancel out. We could just turn into like a big plus sign. So under the radical, we essentially have square root of 40 plus 9, which is just 49. We can simplify that further to just equal 7. Square root of 49 is just 7. So we could say 3 plus or minus 7 over 2 times 2. So I'm just going to rewrite this as 4. So we could say negative 3 plus 7 over 4, as well as negative 3 minus 7 over 4. Where a lot of people get confused is they will either try to divide 4 at the beginning or at this step. You want to divide 4 at the very end. You want to combine all your like terms on the top and all your like terms on the bottom before you try to interact with both of them together. So we have a negative 3 and a plus 7 and a negative 3 with a minus 7. Those are like terms. We can combine them. So we should do that before we touch this 4 on the bottom. So for the term on the left, we're going to do negative 3 plus 7, which is 4. It's essentially 7 minus 3 over 4. And then on the one on the right, we're going to do negative 3 minus 7. Negative 3 minus 7 is negative 10 over 4. 4 over 4 simplifies to 1. Negative 10 over 4 is essentially going to be 2.5, or 2 2/4, or 2 1/2. So our x values are going to be 1 and 2.5. So when we do our quadratic, when we graph this, our x-intercepts are going to be at x equals 1 and x equals 2.5. If this is 2 and 3, we're going to have one intercept here, one intercept here. And again, we're going to be going in a positive direction because our a term is positive. So let's look at one more where we're not going to have a real solution. So if we were to solve for x squared plus 4x plus 8 equals 0, we can see that we can't solve this by factoring. There's no numbers that multiply to equal 8, but when we add them together, we get 4. There just aren't. So, like I said, the easiest thing to do after this is to just use the quadratic formula because it always works. So I'm not going to label everything. I'm just going to start plugging things in. It's going to be negative b, so negative 4, plus minus square root of b squared. So we're going to have 16 minus 4 times a, so it's just going to be 4, times c, so minus 32. That just comes out to minus 16. All over 2 times a, so 2 times 1. It's going to be still solutions here. It's because we have a negative in the radical. If you think, what's the opposite of square rooting? It's squaring. When you're squaring something, you're multiplying a number by itself. So you're going to have 5 times 5, 8 times 8. That also is the case with negative numbers. You're going to have negative 5 times negative 5, negative 4 times negative 4. Whenever you do that, those negatives are going to cancel out and you're going to get a positive number. So it's impossible to square something and get a negative number. So it's going to be impossible to do the opposite. When this is the case, we bring an imaginary I out. You can think of I for imaginary. That's like taking out the negative sign because this is not a real number. We can't actually do this. It's going to be an imaginary number. So we're essentially going to have negative 4 plus or minus I square root of 16, which I'm just going to rewrite to be 4. So negative 4 plus or minus 4i over 2. Now we can't do anything here. We can't combine a real number with an imaginary number. So this is after we've combined all of our like terms, this is when we would divide by 2. So our answer is either going to be negative 2 plus 2i or negative 2 minus 2i. These are not real solutions. So you're not going to get any x-intercepts whenever you go to graph this because we don't have any real x-intercepts. We just have these two imaginary intercepts. So to summarize, we have quadratics everywhere. They're in physics, in business, in calculus. You have to know how to graph them and how to solve them, and these 3 ways are the easiest ways to do them all.